Hello there, welcome to question 8 of our physics exam preparation series. The topic in this question is electric circuits, right? So let us look at the first question that we need to answer. Alright, so we expect the following definition or statement of the law. The potential difference across a conductor is directly proportional to the current in the conductor at constant temperature, right? That's how you achieve the 2 marks there, and the important keywords that are underlined are definitely mark allocated. So therefore, if they are not there, it's very difficult for you to get the 2 marks. So let's ensure that we have those keywords as part of our statement of the law. Okay, good stuff. So let us now go to question 8.2. All right, so 8.2 is asking us to perform some calculations, and for us to do that effectively, we need to work with, circuit analysis and use that as the basis of understanding what's going on here. So what is circuit analysis? It's you seeing the navigation or the path that is followed by the charge, which is then the current in the circuit, right? So you always start from the power source and use the conventional flow of current from the positive terminal to the negative. And you go, my current is flowing there, and we are told that the ammeter reading is 3.5 amps. What will happen here? This point is called the node. That is a connection point, right, in the circuit. There will be current division here. Some current will go down here, and some, or the remaining charge, will go down this other path. So we call this I1, we can call this I2, okay? So I2 will flow through the 3 ohm and the 2 ohm resistor going into this node. So this is the entrance node and that is the exit node, okay? And what will happen? It will meet I1 here, okay, at this point or at this node. So I1 plus I2 will give us what here? Give us the total current here going back to the power source or our battery, if you like. So that is the circuit analysis that we've got. And are we ready now to attend to some questions? Yes. Let us look at 8.2.1. All right, so here we're asked to calculate the external resistance of the circuit, right? So how many resistors do we have? 4. So here, the same current goes through these 2 resistors. So what does that tell us? They are in series. However, these 2 are in parallel with the 1 ohm, right? Because current division happens there. So 8.2.1, we've got 1 over Rp is equal to 1 over 5, the 3 plus the 2, plus 1 over 1, which is that, okay? And if you do the maths there, your parallel resistance is 0.83 ohms, okay? So this takes care of this 3. So now if you have the total resistance for this 3, it will definitely be in series with the 4 ohm. So the total external resistance will be 4 plus 0.83, which is 4.83 ohms. Good. This takes care of 8.2.1. Let us look at 8.2.2. All right, so for the reading that will be reflected here on voltmeter 1 will definitely be obtained through that equation. The external resistance, everything that is going on here, right, times the total current, which is 3.5. We've got 4.83 times 3.5, okay? And let's do that calculation, okay? We get 16.91 volts. 16.91 volts. And this takes care of 8.2.2. Let's go to 8.2.3. Good. How does the reading of V2 compare with that of V1? V1 takes into account all the resistors, while V2 only takes into account what? These 2 resistors. So definitely it will be smaller than. Okay, smaller than V1. Good stuff. Let's look at the next question. All right, so in 8.3.1, we're asked to define what EMF is, and this is the maximum work done by the battery per unit charge. Alternatively, you can say it is the reading on the voltmeter when the switch is open. In other words, when there is no flow of current, what is that reading that we get from the voltmeter? All right, so that becomes another alternative definition that you can look at. Good stuff. Let us go to the next one, 8.3.2. Okay, so the learner is saying that the reading we get on V1 is equivalent to the EMF. Is that true? Of course not. Again, the switch is closed, so it is against the definition that I gave in the previous question. Right? So in other words, we need to know that there is internal resistance which will definitely have some sort of potential difference accumulating here called lost volts. So we know that the sum of the external voltage and the lost volts gives us our EMF, and this is V1. So definitely they cannot be equal because there's a factor here that comes in to give us the maximum work done. All right, so these questions are based on an adjustment where the switch is replaced by a voltmeter, and that will convert the circuit into a series circuit, right? Because the voltmeter has very high resistance, and therefore we are saying that the current that will pass through here will be very little, to the point whereby it is negligible, and therefore if you come here and talk about the 4 ohm resistor, the resistance still stays the same, but what happens if you now convert to a series circuit? You are now saying that I'm going to decrease my current because I've increased my total resistance or the external resistance, right? So if you decrease the current, you then decrease the power. Hence, we have indicated decrease there. Okay, so for 8.4.2, we have to talk about the reading on voltmeter V1. Okay, so we produce the equation here, current times resistance. So what is happening to the resistance? The external resistance is increasing, which will result in the internal resistance decreasing. So therefore the lost volts will decrease. And according to this mathematical equation, if you decrease this quantity, you will end up increasing the voltmeter V1 reading, because the EMF is constant, right? Is the maximum work done by the battery. So therefore, that takes care of question 8.4.1 and 8.4.2. And 8.5 is asking us to explain the reasoning here behind our choice of keywords, and I've just done that, and that is what you can talk about in explanation of increase and decrease. Okay, this takes care of question 8, and we are now moving on to question 9, which will talk about electrodynamics. I'll see you in that segment. Thank you.